Good day friends, welcome to my channel lecture series on power electronics. In this lecture, we'll learn about the synchronous motors, their constructional details, types and the method of starting. Synchronous motors are used in industries for high precision applications. These motors run either at a constant speed, that is the speed of rotating magnetic field, normally represented as Ns, or it does not run at all. They are not self-starting. Similar to every electrical machine, the synchronous motor has also got stator and the rotor. The stator is similar in construction to that of an induction motor. It carries a three-phase winding. The rotor also has a winding and it is excited by a DC voltage, whereas the stator is excited by a AC voltage. There are two types of rotors. One is called a salient pole rotor, and the second one is called the cylindrical rotor. The stator of a synchronous motor consists of a three-phase winding and it is given a three-phase AC voltage supply. Even a three-phase induction motor has a similar construction. There are two types of rotors available for synchronous motors. One is called as a salient pole or projecting pole type of rotor. The second one is cylindrical type rotor. As can be seen from the picture, the salient pole rotor has the poles seen as projected out, and in the case of a cylindrical rotor, the poles are not seen projected out. The rotors of the synchronous motors can be visualized like this. The salient pole rotor is visualized like this, where we can see the poles as projected as north, and south, and a winding is made on the pole force. The supply, DC supply, is given through slip rings and brushes. In the case of a cylindrical rotor, the poles and the coils are not separately seen. It is a cylindrical structure, and there also the supply for the winding is given through slip rings and brushes. The salient pole or the projecting pole type of synchronous motors are used in hydraulic turbines which run at low speeds between 50 and 300 rpm, as a large number of poles are required on the rotor. Non-salient pole or cylindrical type of synchronous motors are used in turbo generators which run at high speeds between 1500 and 3600 rpm. They are rated up to 2000 MVA. The synchronous motor as a whole can be visualized like this. The stator has a three-phase winding and it is supplied by a AC supply. There is a rotor. In this case, a projecting pole type of rotor is shown. It has a winding to which a DC supply is given. When the AC supply is given to the stator winding, it produces a rotating magnetic field. In this case, it is shown as equivalent to two poles marked as Ns and Ss to represent that it is the stator's pole. Ns is north pole of the stator, Ss is the south pole of the stator, whereas the poles of the rotor are marked simply as N and S. The operating principle of synchronous motor is explained using this image. The stator of the synchronous motor carries a three-phase winding and it is given a three-phase AC supply. When three-phase AC supply is given, a magnetic field of constant magnitude but rotating at a synchronous speed is produced. Let us assume that the magnetic field produced is rotating in the clockwise direction, and let us assume that this winding is wound for two poles, say Ns and Ss. So when the supply is given, a magnetic field is produced which is equivalent to two physical poles. The speed at which this rotating magnetic field would rotate is given by the equation Ns is equal to 120 F by P for a frequency of 50 Hz and for the number of poles of 2, the speed of the rotating magnetic field will be 3000 rpm. The rotating magnetic field is rotating at 3000 rpm. The rotor is shown to be present in a position shown here, and the rotor poles are marked as north and south. Let us assume at any instant of time the stator magnetic poles NS and SS are aligned in the line AB. So when it is aligned in the position AB, and if the rotor's pole, north pole, is closer to the north pole of the stator, it tries to repel. As we have assumed that the rotating magnetic field is going in the clockwise direction, when north pole of the rotor and the north pole of the stator come close to each other, the rotor would try to move in the anti-clockwise direction. We know that the rotating magnetic field is rotating at a very high speed. The rotor is a heavy mass, and when it tries to repel from this position, from the point A away from it, by the time it tries to move away, the stator magnetic fields, because it is rotating in a very high speed, would have changed their positions. The south pole of the stator would have come to the point A, and the north pole of the stator would have come to the point B. Now, because the south pole is closer to the north pole of the rotor, this rotor tries to move towards the stator magnetic field south pole, and it tries to move in the clockwise direction. Initially it tried to move in the anti-clockwise direction. Now it is trying to move in the clockwise direction, but before it could move to the clockwise direction, again the poles of the stator would have changed their position. The rotor has a high inertia, heavy mass, and so it will not be able to move as fast as the stator magnetic field. Because it is unable to move to such a high speed, it stands still. It will not be able to rotate. This is the reason the synchronous motors are not self-starting. There are two major reasons why the synchronous motors are not self-starting. One is the rotating magnetic field rotates at a very high speed, and the second reason is the mass of the rotor is very high. So it is not able to move with the same speed as that of the synchronously revolving magnetic field of the stator. If by some means this north pole comes in contact with the south pole of the stator, it will be able to get attracted to it and will be able to move in the same speed as that of the synchronously revolving magnetic field. Since the synchronous motors are not self-starting, different methods are used to start the synchronous motors. They are using pony motors, using small DC machines, using damper winding, and it can even be started as a slip ring induction motor. In all the methods used for starting the synchronous motors, the main idea is to bring the rotor to the synchronous speed first and then give the excitation to the rotor. So once the rotor starts rotating at a synchronous speed, it will be given the excitation, and then the poles will be getting attracted to each other, north pole of the rotor and the south pole of the stator. Then the motor will be running at the synchronous speed itself. One of the methods used for starting the synchronous motors is using pony motors. By using small pony motors like small induction motors, we can start the synchronous motor. This small induction motor is coupled to the rotor of the synchronous motor. The function of this induction motor is to bring the rotor of the synchronous motor to the synchronous speed. Once the rotor attains the synchronous speed of the pony motor, it is decoupled from the rotor. Then the synchronous motor continues to rotate at synchronous speed by supplying the DC excitation to the rotor through slip rings. The motor used as a pony motor must have less number of poles than the synchronous motors Another method used for starting the synchronous motors is by using small DC machines. Here we use DC motor instead of induction motor to bring the motor to the synchronous speed. Once the DC motor brings the rotor of the synchronous motor to the synchronous speed, the motor starts acting as a DC generator and starts giving excitation to the field winding of the synchronous motor. Another method of starting the synchronous motors is using damper winding. The damper winding is copper bars circuited at both the ends, similar to the squirrel cage rotor of an induction motor. When the supply is given, after the rotating magnetic field is set up by the stator, the presence of the damper winding makes it start as an induction motor. That is, the rotor will start rotating at a speed which is at less than the synchronous speed. Now, when the excitation is given for the field coils, the rotor will be pulled into synchronism and it will start working like a synchronous motor. Once the rotor starts rotating at synchronous speed, the relative motion between the damper winding and the rotating magnetic field will be equal, and hence the induced EMF and the current will be zero. So the damper winding will be out of the circuit. The damper windings are used for starting purpose only. Synchronous motors can also be started as a slip ring induction motor. The rotor of the synchronous motor can be started as a slip ring induction motor by introducing resistances in the rotor circuit through the slip rings. As we can see in this image, there is a two-way switch. When the two-way switch is put on the left side, a DC supply is given, and when it is put on the right side, the resistance are included in the circuit. So initially, very high value of resistances are included in the rotor circuit when the switch is put on the right side. So because of the high value of resistances present in the rotor circuit, the rotor will start at a low speed. Gradually the resistances are cut off, the speed increases, and when it reaches a nearly synchronous speed, the rotor is given a DC excitation by throwing the switch on the left side. Now, because of the excitation present, the motor will be pulled into synchronism and the machine will start running at the synchronous speed. Of all the methods discussed here, the damper winding is the most commonly used method for starting the synchronous motors. Synchronous motors find applications in many places where constant speed is needed. In addition, these kind of motors are used in grinders, rock crushers, ball mills, steel mills, metal rolling mills, cement mills, rubber and textile mills. Also in centrifugal pumps, air compressors, fans and blowers, timers, clocks, indicating, regulating and controlling devices. In this lecture, we have seen the constructional details of the synchronous motors, why the synchronous motors are not self-starting, and the methods available for starting the synchronous motors and the applications of the synchronous motors. Hope this clarifies all the basics related to the synchronous motors. Thank you.